Well, I am going to get started, everybody. Good morning. Today we're switching topics completely. We're moving over to a curriculum called Interactions. Interactions was a joint project between the Concord Consortium and Create for STEM, funded by the United States National Science Foundation, to really try and improve students' understanding of why materials, both at the macroscopic level and the microscopic level, tend to stick together. It was also an effort to really try to engage kids to learn science by doing science, really having them experience phenomena and make sense of those phenomena. It's basically intended for ninth grade, 10th grade physical science, at least in the United States, that's where these learning goals are at, or an integrated for integrated science students. You'll see that we have various units. We're going to focus primarily in our work today and tomorrow on units 1 and 2. This is actually in the United States. This curriculum is actually an entire 9.5 months worth of curriculum materials. It is all open source, which means you can take it and use it. There's 2 versions of it. There's a version that's on the web on Concord Consortium website that we'll be using primarily. But there's also a paper version, PDF version, that I'll give you access to later on during the day as well. So depending on how you want to use this, you can either sign up and go into Concord and use it on the Concord site. There's actually a lot of advantages to use it on the Concord site because you can actually see the students who are doing their work and how much work they've completed. So there's some advantages by doing it on the Concord site, but you're more than welcome just to use the pencil paper version, and I will show you that. So you can ask, why did our National Science Foundation actually support this effort to create materials to really help kids understand why materials stick together? Well, in the United States, understanding of chemistry and bonding was always had to do primarily with kids learning the octet rule and about how you have to have 8 number of electrons in the outermost shell. Of course, that's a description in some respects, and it's not a reason. The reasons why materials stick together is because of the forces, the attraction and repulsive forces that exist. But very few people understand that. So if you look at this graph that's on this page, you will notice this is percent at the top level, and you'll see various ideas related to understanding chemistry, like, for instance, how the structure of the molecule might determine its properties, how the arrangement of the molecule might determine its properties. And you'll notice when you go back to structure, undergraduates have a pretty good understanding. This, by the way, the undergraduates here were students at a very good college. University was it was when I was still at the University of Michigan. So these are top-notch students. And you'll see at the high school level, kids are beginning to get this idea that structure will help determine the properties of matter. Not necessarily too much at pre-chemistry in high school. You'll see it's very low, and at middle school. At the arrangement, how the arrangement of a molecule, which is really critical, can really impact its properties. You will notice that even at this really good university, the University of Michigan, kids, not very many of those students had a good understanding of it. So it's a very hard, there are some high school, it's a very challenging concepts. Now, when you go to forces, the forces that actually hold molecules together, that's even more challenging. You will notice that less than 20% of the college students have an understanding of that. We get to ideas like spaces within molecules, the consistency of their structures. We see everybody doing pretty good, but it's these forces that are really, in many respects, very problematic. And the reason why I say that is understanding the forces that hold things together, the forces that cause things to stick together, is critical for modern science. This is understanding forces is the whole foundation of understanding nanoscience and being able to make new molecules, be able to make new structures, new compounds, new molecules that have different properties than other molecules. So understanding forces and what holds things together is simply a critical idea. And yet, even at the undergraduate level, we don't, at a place like University of Michigan, we don't see very many kids having this rich understanding of it. So that was the motivation in building this unit, is to help kids build this understanding of a really rich understanding of these ideas. I'm actually very proud of this unit. We were actually one of the first. We were the first group, Concord and myself, Dan Damlin, my good colleague and co-PI in this, along with Sean Stephen from the University of Michigan. We were the first group to ever receive a high quality design badge that met the criteria of living up to the vision of the framework for K-12 science education in the United States. Now, I'll give you this link later on again, but if you see interaction videos, if you click on this link, and I'm going to stop sharing.
I was blind from birth, so reading print with.
I'm going to stop sharing so I can take you there. And I'm going to share again. And if you go here,
material wasn't possible before I could even ask. Huntington asked me if I would like my statement to Braille. Imagine that.
This is the penalty.
Away.
Oh God! Oh my God! Come on! Oh my God!
Okay, that's the penalty of using YouTube without paying for it. But you'll see if you go here, there's a series of videos that will talk about the interaction materials. Now, the first one is basically just me, along with my colleague, talking about the value of the framework at NGSS. But if you go to this third one, called Developing and Using Models of Electrical Interactions, this is where you start to get into images of what it's like to teach interaction. This is, I'll just click on that one.
Early in this unit,
So this is Kristen Mayer, who was a former high school science teacher, and then she decided to get her PhD. And she worked with me very closely on this particular project. And then she enacted the project in her classroom. This was one of our first enactments. And so we have video of Christian showing how interactions works, as well as how what it looks like in the classroom, and she talks about it as well. So you might want to take a look at these. I think when you do professional development around interactions, you'll find them very valuable. They were at one time. Well, you can notice that they're published. The creation of these videos were actually supported by the National Science Teachers Association in the United States, and we developed it 8 years ago. You'll see, but since then we had 47,000 views. That's not bad. It's pretty good. So you might want to take a look at these. They're actually very good. There's a series of 6 of them, and I'll send you a link. Since I put this link up, I actually had one of my tech people put all the links for us all together in one spot. So I'll show you that probably when we start doing professional development. But you probably want to try to come up to this link and play these videos because they'll give you a really interesting insights in how to support kids at the high school level in supporting them how to do models and explanations. So I'm going to stop my video again, and then I'm going to go back and share. We're going to stop sharing, and I'm going to come back and start sharing again. So these videos give you a really nice vision of what it's like to teach interactions. And perhaps tomorrow I'll go a little bit more deeply into just at least one of those videos so you get a sense of what's going on. So as I mentioned, interactions is driven by kids experiencing phenomena, them raising their own questions related to those phenomena, investigating by engaging in three-dimensional learning. And remember, what is three-dimensional learning? And we've talked about this several times. So three-dimensional learning is using disciplinary core ideas, the big ideas in science. And I'll get a little bit into what are the big ideas in this particular unit. The big ideas of science, scientific and engineering practices, and then these these ideas that cut across disciplines, like systems, models, cause and effect, properties. And of course, it's by building these models and using some disciplinary ideas that they learn new ideas and also raise new questions. By the way, at any time today, please don't hesitate to interrupt me or put a note in the chat, and I can sort of follow along and answer questions as you have them. So interactions, as I mentioned, focuses on three-dimensional learning. The goal is for kids to really develop powerful understanding of electrical interactions because it's electrical interactions that hold the world together. And so you really want to, that's a critical concept. We engage in modeling. The practices we engage with much in this unit are modeling, constructing explanations, and kids doing investigations. The cross-cutting concepts that we focus on are primarily cause and effect, systems and systems models, and matter and energy. And the core ideas are the types of interactions that exist because interactions can be very strong, like we see in bonding, like the bonding and it happens in diamond, or it can be fairly weak, like the attractions that exist between carbon dioxide molecules at very low temperatures. And the other idea that we focus on, because it's so closely intertwined with the notion of forces and interactions, is energy. And we really try to present a unified vision of what energy is all about. So Unit 1, we also focus very similar. You'll see one of the nice things about the water quality unit that Ann just got done working with, and the interactions unit, as well as the health in our hands unit that you'll experience, is they all have somewhat similar structures. They all focus on phenomena. They all focus on three-dimensional learning, and they also focus on kids answering questions. So the interactions curriculum, as you build the idea, the unit builds extremely nicely throughout the year. So the idea of coherence is extremely strong within these materials, and each unit actually builds upon each other. So Unit 1 focuses on why does some clothes stick together when I take them out of the dryer? Now, this might be a question that in your nations, your countries, you might need to modify, because I'm not exactly sure how many people in your various countries use dryers, but in the United States, lots of kids use dryers. I mean, lots of families use dryers. And as a result, often when you take clothes out of the dryer, the clothes stick to you, right? They get attracted to you. Why is that? Why is it that, so that's unit 1. And unit 1 really focuses a lot on helping kids understand, and we'll get more into this today. It really helps them understand ideas related to static charges, why things stick together because of electrical interactions, not at a dynamic level, but at a static level. So if I take one charged particle, another charged particle, why do they stick together? So that's what unit 1's about. Unit 2 really starts getting to the nature of why things react. And of course, we move in chapter 1 from a macroscopic level to a microscopic level. So the kids can experience at the microscopic level the things actually sticking together. And then they try to understand why does that happen. And so we go at the microscopic level to talk about electrons and electrons that are in atoms. Unit 2 actually focuses on the nature of a chemical reaction. And why is it that sometimes just a small, tiny spark can cause a huge explosion? Many chemical reactions won't take place unless they have a little bit of energy supplied to them. But then when they get that little bit of energy supplied to them, why do they react so vigorously? Unit 3 builds on unit 1 and 2 to focus on what powers a hurricane. So hurricanes, tornadoes, cyclones that you have more in your areas are very powerful storms and can cause just tremendous destruction. Where does that energy come from? Why does that happen? And so they really explore that issue. And then unit 4 goes into why is a temperature, and this unfortunately is in Fahrenheit, so why is a temperature of 107 degrees Fahrenheit so deadly to living creatures? And every mom and dad knows that when your child's temperature starts to reach a certain point, you have to really worry because they can die. So chapter 4, really gets into that issue. So those are the 4 units. Unit 1 and unit 2 really build on fundamental knowledge, whereas unit 3 and 4 make use of that knowledge in new situations. So it's a fairly interdisciplinary unit when you look at in this perspective, where 1 and 2 really build the fundamental knowledge of both forces in interactions at the molecular level and energy, and unit 3 and 4 really focus more on applying those ideas to explain some really interesting phenomena. So as I mentioned, the interaction curriculum aligns with 3-dimensional learning, the idea of using both disciplinary ideas, in this case, the atomic nature of matter, the balances of charges and forces, and energy. So those are the big ideas that students will come away learning from this unit. And those are critical disciplinary ideas that are so important to understand other aspects of science. And then from the cross-cutting concept perspective, the notion of cause and effect, how one thing can affect another thing. Patterns, scientists always make use of patterns. And then structure and function, how the structure and function of various aspects can really impact what they look like at the macro level, and then finally matter and energy. And the practices we really focus on helping kids develop are the use of models and constructed explanations. You know, most people, and go back to this slide just for a second now that you've seen the disciplinary ideas. Most individuals really don't understand where all the energy, the force that a cyclone or a hurricane has, where does it actually come from? Like, why is it? And why is it always accompanied by a bunch of rain? What's going on, right? So most people, this is a really interesting concept about how it takes energy to cause materials to separate. And then of course, then when they come back together again, they have to release energy. So if you think about the boiling of water, we have to add a lot of energy into making water evaporate. Right? Think about boiling water. Water will stay at 100 degrees Celsius for a long time while it's boiling, right? Until it's all gone. Of course, then that absorbs a lot of energy. Not only does it take energy to get up to its boiling point of 100 degrees Celsius, but once it reaches that boiling point, you really have to put a lot of energy in to cause it to boil, to evaporate off. So then you have to ask yourself, what happens to all that energy? So when water molecules come back together again to form liquid water, that energy has to be released. And that's all the energy that we always see in a hurricane. And very few people understand those ideas because they combine the notion of forces, energy, and molecules. So the two units we're going to focus on primarily during our work together are going to be Unit 1, where we're going to first explore macroscopic level phenomena related to electrical interactions. We're going to see how patterns in how charged objects interact, and we're going to use those patterns to explain phenomena. And we're going to get into a really challenging idea, but was a really critical idea, the notion of electric fields and forces. So most students don't understand the notion of electric fields. If you remember back to your own experience, perhaps I would imagine in introductory college physics, it was always given to us by some kind of right-hand rule and some kind of equation, and no one ever understood electric forces. We all did a nice job of memorizing it. No one understood it. Yet understanding electric fields is really critical. And it's one of the, it's now become a really major idea at the lower secondary and upper secondary levels. Unit 2, we're looking more at energy at the macroscopic and microscopic level, and how energy is involved in interaction between atoms, particularly in bond formation. And then Unit 3 and 4, as I already mentioned, these deal with applications of those ideas to real-world phenomena. So perhaps one of the most challenging but misunderstood ideas is the idea of energy. Energy in science is a really critical idea. But in many respects, we continued to teach energy like we did in the 1800s. And that really confuses kids. And so what we're trying to do in interactions, which is basically the worldview of what most scientists hold of energy now, is provide more of a unified view of energy. That at the macroscopic level, and by the term macroscopic, I mean at the large level here, right? What we can see, what we can feel, what we can touch. At the macroscopic level, energy manifests itself in a variety of different phenomena. So we experience energy by motion, light, sound, electrical and magnetic field, and thermal energy. Those are the way in which energy is manifested. But that's not what energy is. And that's where a lot of the confusion happens, right? So energy can be manifested, and we see things, moving objects is a great way of thinking about, energy and how energy can transfer. Electric fields is another one, right? The movement of electrons through wires as a result of electric fields is another really critical idea. But that's how it's manifested. That's not what energy is. All those manifestations of energy can be classified as kinetic or potential energy. Not sound energy, not chemical energy, not electrical energy, only two kinds of energy. And as physical scientists, if we focus on helping kids just understand kinetic and potential energy, we'd be a lot better off. And so interactions really takes a deep dive in really trying to help students understand kinetic and potential energy. The idea that there are different forms of energy, like thermal energy, mechanical energy, is really misleading. So we don't get into that. We basically talk about energy is manifested in these different forms. So energy can be shown in these different forms, but that's not what energy. Sound and light are not forms of energy. They're just phenomena that allow us to talk about energy being transferred. Right, so we're going to talk a lot about as you'll see the interactions unit. It really focuses on the transfer of energy, and if we can help kids understand how energy transfers from one spot to another spot, rather than talking about a variety of different forms of energy, we'll be a lot better off. So kinetic energy is the energy of motion. And as you all know, it's proportional to the mass of the moving objects, and it grows with the square of its speed. Now, interactions gives you also, for those of you who are really teaching in high school, you can really get into more quantitative aspects because of that. Thermal energy, on the other hand, is the random motion of particles. And it's a really important idea to understand, because often when energy is transferred from one place to another spot, there's never a loss of energy. Energy can never be created or destroyed. That's such an important idea about energy. But often what it does is it gets dissipated. So we well know that when one object hits another object, if there's a fairly clean transfer, pretty much the energy gets transferred to the other moving object. But a little bit of it actually goes to heat up the object it hits, or hits up the environment. So energy is always dissipated. I don't want to say lost, because it's not lost. It just goes to the environment. Energy is never created or destroyed. And understanding thermal energy as the random motion of particles, and as the more they move faster, the greater the temperature would be, right? The more energy there is a way of understanding where that energy goes when energy is transferred. So it's not lost, it's just dissipated out into the environment. Potential energy is the energy stored in fields. And of course, one of the simplest ways of understanding that is thinking about gravitational energy. Gravity always also has a field, right? So this is why when you have in gravity, if I hold something high, there's a gravitational field. If I let this go, this thing moves, and the potential energy I had up here is released as the object falls. And so it goes from energy stored in the gravitational field to transferring the energy to the motion of this object. And as I just said, it's defined, potential energy is defined as the difference in energy compared between some arbitrary reference point, like I just said, at this point, and then when it drops and reaches my hand. And often a change in potential energy is accompanied by changes in other forms of energy within the system. So energy, when there's a change, of course, in potential energy, there's always energy transferred into the system or out of the system. And so you can see some mostly change in either thermal energy or motion energy, or kinetic energy, either the motion of a larger object or thermal energy. So potential energy is really, and we'll get deeper into this. I'm just kind of trying to introduce this as we at the beginning here, because there's so much to do with energy in the interactions unit. Potential energy is the change in relative position of objects. And in the particular unit that we're going to be working on, which has to do more with electrons, it's a change in the charged objects. So when those charged objects change position, you're going to get a change in potential energy. And so that notion, which is just key to understanding why bonding occurs inside why bonding occurs. Bonding occurs because there's a change in the amount of potential energy to a lower state of potential energy when everything bonds. So we'll see as we get into chapter 2 and at the end of chapter 1 that matter is most stable when it's stored in electrical magnetic fields, and in many respects it's a very low potential energy, because you really have to put a lot of energy into a system to take it apart, right? This is the whole explanation. Why do you have to put so much energy into boiling into water to cause it to boil and evaporate? Because you're breaking connections, and so you're putting energy in, and then that energy is stored in these molecules in these different forms. So understanding, as I mentioned, understanding energy conservation, which is what interactions is all about, is key to understanding many of the ideas that we're going to be talking about. Energy conservation and transfer are the two big, powerful concepts that energy interaction focuses on. Once again, energy is best understood at the microscopic level, the movement of particles and electric fields, and that's what we're going to be talking about. And of course, a big part of the world today is understanding, the climate change and the sun, and we made great advances lately on trying to use solar energy to create electric vehicles, etc., gather energy. So a critical aspect of understanding energy is this notion of electromagnetic radiation. And so we'll be getting into those ideas as well. So I'm going to stop there just for a minute because I've been talking a long time. And I just want to see if there's any questions. I'll just wait a minute to see if anybody has a question. Okay, if no one has a question, I'm going to move on. So Interactions has rich student materials, which combine firsthand experiences, kids experiencing phenomena with computer simulations, demonstrations, and reading. So it's a very active, live curriculum. All the materials are on a website, which we'll go into just a little bit. So if you wanted to use the materials electronically, you can, or as I said, there is also a paper pencil version that you can download. There's also a really rich set of teacher materials that you can download that are very critical that you really do need to read to really understand how to interact with interactions. They're very educative in that we put lots of supports in there to really try to support the teacher in knowing how to do this new kind of teaching. And actually in the United States, I can't say this for your nations, but in the United States, many teachers just have difficulties understanding energy and forces. And so we really try to put a lot of support in there for teachers to understand these very complex ideas as well. There's a print version, as I said, and if you want to use the print version, you can just I'm going to go there right now so you can see what this looks like. This is going to be your choice. I'm going to be using the electronic version of it because I think they're very nicely done. But some people can't use the electronic versions, so I'm gonna use the show you a little bit about the PDF format now. You might want to follow along with me and download it. So I'm going to click on it. And then I have to stop sharing so I can go to the other spot. So when I clicked on it, then this window popped open, and you'll see that there's this is the Interaction Teacher Guide. The TG stands for Teacher Guide. So if you wanted to download and read the teacher guide from here, you're more than welcome to do that. This is Unit 1. So student work, that's what the SW for. So this is Teacher Guide. SW stands for Student Workbooks. So this is Unit 1. And you can click and download on it. Unit 2, Unit 3, and 4. And there's also tests and rubrics. So we have test materials and rubrics along with it. So if I click on Unit 1, it's going to open up as a PDF. I have to stop and reshare. So now you can see this one, and these are the student materials. And it gets in here and it says activity 1, and students can do the activity. So those are a really nice source of materials if your students don't have access to computers to be able to use the computer version. Although I'm gonna use the computer version for our work today, and I'm gonna try to get you to also sign on. But these materials are there in a PDF form for you to use. So we're going to focus primarily on Unit 1 today. And again, throughout our work, we're going to experience throughout today and tomorrow. And when we go into the more of the consulting sessions, we'll be focusing on Units 1 and 2. And you can get to them, and I'm going to go to them just in a second. Here we go. So I'm going to send you guys off, and I'm going to have you actually go into the teacher materials and look at them. But first, I'm going to give you sort of an overview of what you're going to see when you go in there. So I'm going to click on this link. I've given you a variety of different links to get to the Concord site, but I'm going to click on it. Then I'm going to have to stop and change screens. And when I clicked on that link, this is what comes up. Now, the first thing I'm going to ask you to do is register. Now, you can look at the student materials online without registering, but you can't look at the teacher materials. So if you want to look at the teacher materials online, then you have to register. So the first thing I'm going to ask you to do is register. Now, I can't look at the teacher materials online either unless I log in. So I'm going to log in. Okay, so I logged in. You're going to have to register and log in. And when you do that, you open up to this page, which you should take a look, just do a quick read of it. And it looks pretty similar to what the paper version looks like, except of course when you're on the the online version, you can click on these various buttons and they're actually active. They're not active on the paper pencil version. Oh, I just want to go back for 1 second. So by the way, on this page, it says, look at these NSTA videos, and it says watch the videos. That link is no longer active. That's how come I gave you a link to it. So these are actually supposed to be a link to the same videos you saw, but for some reason, NSTA does not have them. At least the last time I looked, they weren't active, and that's why I gave you that link. So let's so here we are. We're at unit. We can look at various. I logged in here. Okay, so here we are. I logged in, and now I can go look at one of the units. So what I want us to focus on today, which I'm going to give you about 25 minutes to sort of look at the student. I want you to register, and I want you to look at and discuss some of the key features you see in Unit 1. Now, when you open this up, I clicked on Unit 1. You'll see there's a pre-test if that you can give your students if you want to give them a pre-test. But then here's here's all of Unit 1, Part 1, investigation. So Unit 1, investigation 1. And you can, when we get to the consultation sessions, I will explain to you how to assign various lessons to your students and how you can see student work as a teacher, but we're not going to do that today because we don't have enough time. You can see here, you can get access to the teacher guide. You can copy it. You can also read more about what I just had. So you can go to the teacher guide, and we're going to go to Unit 1, investigation 1. And so I'm going to click on teacher guide. And that opens up the teacher guide. Of course, it takes you to the PDF is what it does, right? Because the teacher guide is not online, just the student materials are online. So you can get to this in either two ways. You can download it from before, or you can go on this system. I would like you, however, to go in and see if you can't register. If you can't, if it takes you more than five, I'll pop into the breakout rooms to see if you're struggling registering. I don't think there should be any issues, but if you're having trouble, registering, then just go right to the teacher guide that's on in our Google Drive. So what I'd like you to do is you're going to work in breakout groups, and I'd like you to explore the structure of the teacher materials. How are they put together? Try to see if you can't read through Unit 1 and talk about what you see, right? You might not get through all of it, it's okay, but look at the structure and how it's set up to help you in your work. Don't go to the student materials now. We're going to do that once we come back. So we're going to have a session first on, you're going to look very closely at how the teacher materials are put together, and then we're going to go and look at how the student materials are put together. So I'm going to stop sharing this, and then I'm going to go back, share my screen, and I'm going to go to my PowerPoint again. So this is what I want you to do. You're going to go in the breakout group. So Buren will put you into breakout groups. You're going to explore the structure of just Unit 1, Part 1, the first investigation. You're going to explore it. You're going to look for the main features. How is this thing put together? And I want you to really try to register. I'm going to give you 25 minutes to do this because I really want you to dig into the materials, understand how they really work, because there's no way that you and I are going to be able to go through. It's too big of a unit to actually go through each one of the lessons and the activities in a 2-hour session. because it's basically unit one is literally takes about 8 weeks to accomplish. So, and then same thing with unit two. So I'm gonna send you off, Buren's gonna put you in the groups. I'm gonna give you a couple of minutes to get started. And then I'm gonna jump into the breakout rooms to see if you're having trouble registering. So there's about 19 of us online right now, so Buren, I think we probably wanna have at least 4 breakout rooms. So that,
Okay.
let's put everybody in 4. You know, if there's 3 to 4 people in a breakout room, that would be great. So let's
Okay.
put people in breakout rooms. And then I'm gonna give you 25 minutes, so we're gonna get back together again around 20 after the hour. And as I said, I will come into each breakout room, moving back and forth through them to see if you have questions with respect to anything I've talked about today, up to now, or also the structure of the materials. And then we're gonna come and we're gonna discuss the materials as a group. Okay, so Bruin, let's put people in the breakout groups.
Okay, sure.
You know, okay, good, I see that there's people already signed up. It's always good to hear. Okay. Did you get signed in all right?
Yeah, I'm good. I'm kind of
Okay.
reading the teacher preparation is the same with teacher guide, right?
Teacher preparation, and teacher guide are the same thing, yes.
Ah, okay.
And so everybody's signed in and they're just reading?
I guess so.
I guess so. All right, so maybe in about 10 minutes or 15 minutes, you want to start discussing among each other or sooner than that about what you see and questions and comments you have for me.
Mhm.
I'm gonna pop into one of the other breakout rooms and see if they have any questions. If there's no questions here, I'll leave.
Okay.
No, we are still reading on the material.
Okay, so you're still reading, but everybody was able to sign in?
Yes, I did register earlier. I think everyone also did manage to register.
Okay, great. So continue reading and I'll come back in a little while, maybe in 5 to 10 minutes to see if you have any questions or whatever. I don't know if you have any questions now. I think you're still reading.
Yep.
Okay, good. So I'm gonna go see if the other group has any questions, or if they had trouble signing in. I'm glad everybody was able to get signed in. And I'll come back in 5 to 10 minutes and see how you're doing.
Okay, thank you.
Thank you. Sherry, are you having difficulty signing in?
Um, not really. I'm just entering the website actually, having a small internet problem just now, but it is okay already. I'm trying to
Okay.
explore the teacher structure. Thank you, Prof.
Okay. And Corinda, did you get signed in as well?
Yes, I'm just filling up the information. Uh, I think I'm okay now. I think I'm already in the website. So, should I reading all the units?
You can't read all the units. You want to just look at unit 1, right? You want to get a sense of what the
Okay.
structure is of the teacher materials in unit 1.
Okay.
Okay, just look at unit 1, investigation 1, just to get a sense of what the structure is of the materials.
All right. Thank you, Joe.
Okay. Okay, and I'll be back in 5 to 10 minutes to see if you have any questions.
All right. Thank you.
Okay, bye-bye.
Bye.
Thank you.
Both of these things should have metal should have the same electricity strength or power, then they will bind together.
Yeah, they should have metal because metal is a conductor, Bu Murni. So it will make easier for electron to move. Hello,
So,
Prof. Joe.
I see.
hi, everybody. I see your, I think this is the student materials. I'd really like
Oh,
you to,
really?
yeah, I want you to look at the teacher materials. Yeah, I can tell
Okay.
looking at this. This is the,
Okay, sorry.
these are the students. So we're gonna look at the students, but not right now. So it's
Okay.
better to look at let's look at the teacher materials first. And I'll tell you a little,
Okay.
So that's why it consists of some question because for students.
those are the
I'm
student
sorry,
materials.
but could you help me because I cannot find that.
Okay, why don't you,
I'm sorry, it's not familiar. Yeah.
why don't you share your screen and
Oh,
and
okay,
I'll try
okay.
to navigate you through it. How's that?
Okay, okay, well, wait. Okay, well, is this right?
Okay, so now you're signed in because it says log out, so that's good. So now scroll down,
Mm-hmm.
keep scrolling down. Okay, so
Okay.
now let's click on unit, go slowly, go back up. Go up,
Okay.
up, up,
Sorry.
up, up, up,
Up,
up,
up, up.
up. Okay, stop. Now
Okay.
let's look at unit one and it says teacher guide.
Oh, I see this one. Okay.
That's a teacher
Okay.
guide.
Oh, thank you, Joe.
No problem. That's an easy one.
Yeah. Oh, I see this one. Okay.
Right. So what I'd like you to do is explore, you have about 15 minutes to explore the structure of the teacher guide and get a sense of how they're put together. And then we're going to come back and we're going to talk about those just for a little bit. And then I'm going to break you out to go look at the student materials. Again, unit one student materials. Okay?
Okay,
Any other
thank
questions? Just scroll down. Was everybody else able to get on them?
um well, I help them to open this link because some friend maybe cannot open the website.
Okay. Because they couldn't register?
Yeah.
What was the
Um,
difficulty in registering?
maybe
My case is
Bu Murni,
because
yeah.
I joined from other island now. I'm in Kalimantan, so we have difficulty in internet connection. And I joined through
Oh,
my handphone, so it's quite difficult for me to log in and register. So I will
I see.
try later when I was in hotel with the good internet connection. Now I'm just go outside, so have difficulty on internet connection.
Okay, sounds good. Yeah, you do need to have, or, if you can't, if you have any kind of connection at all, you should try to download the PDF because the PDF
yes. Okay.
is okay. So,
Yeah.
Sure.
okay, well, I'll
Okay.
let you guys read and then I'll come back in 5 or 10 minutes to see how you're doing. And then about 20 after, we're gonna go back into the larger groups.
Okay. Thank you, Joe.
You're welcome.
Yep. Bu Murni, I think I will send to WhatsApp group Bu Murni.
Okay, thank you.
Percetakan pertama itu dia nyetak 100 buku gitu. Nah, nanti ini
So I'm just gonna hang out here for a while because I know how to move from one breakout room to the other breakout rooms, but I don't know how to get back into the main room. So maybe I just leave the room.
Yeah, you can just leave the room and you will
Yeah, I
get.
got it. Leave breakout room, right?
Mhm.
Malaysia, which have high humidity, there would be some problems in making it happen, or possibly for it to happen requires a bit more extensive action.
Peter, I think you're absolutely correct. If you have high humidity, some of these things might not work by experiences. You're absolutely correct. We did try to provide some videos. I mean, the Van de Graaff should work. I don't think there should be any issue with a
Okay.
Van de Graaff, but it's the rubbing ones that might not work.
Yep. Because my
Unless you're,
student did try and it doesn't work. I mean, they have cases where they try to demonstrate on static electricity, say view it on YouTube, but it just doesn't happen.
that's right. Unless you're, if you're in an air-conditioned building, it would probably work okay.
Oh, yes, okay. Thank you
I
for the
don't know if the
suggestion.
schools are air-conditioned or not. I do know that, at least I know Thailand is extremely humid.
Some of our room is air conditioned. Maybe we can actually do the experiment in such room then.
Right, I'll talk about this when we go look at the student materials. There's a wonderful demo with Scotch tape. You actually need
Ah.
two people to do it. So I think you raise a really good point that you're gonna have to try out some of these videos. You're gonna have to try out some of these activities to see if they actually work or don't work in a humid environment. Because I do know that when it's really humid, particularly rubbing the rod
Yeah.
won't work. I'm not sure about the balloon. I never tried that. So, but that's a really good point. Well,
Also, that's actually a good way to basically probe the students further by saying why it doesn't work in Malaysia or something with some places with high humidity, why it doesn't work as compared to places that have
right.
low humidity. Yeah.
Right, I don't mind, sometimes using videos are okay, but getting more of the kids to experience the phenomena is really a critical aspect. There's that one, I don't know if you saw that one activity where you can take a plastic water bottle, like buy a $1 bottle, and
Yeah.
you can actually charge it. And you can move it, you can get it to move back and forth with your hand. And there are kids, ninth graders who just love doing that because they feel like they have some control, magical control over that bottle, right? It's really quite cool that you can rub that bottle and then take your hand and move that bottle around. And so kids really find that fascinating. I've seen, I've actually seen juniors in high school. So 16-year-olds, 17-year-olds spend 10, 15 minutes just doing that, right? I mean, so it's kind of an interesting phenomenon. So hopefully some of this will work in your classroom. I'm gonna have to jump into another breakout room, but let's bring that point up, Peter, when we go back into the full group, because I think that's a really important idea to discuss.
Okay.
Okay, I'm gonna jump into another breakout room.
Hello, Peter. Hello,
Oh.
Jim. I would like to discuss a little bit, my background in
Okay.
ring, So at the moment, I figure out how.
Like experiment.
Yeah.
Yeah.
So the way the way the Concord system works is they call everything an investigation, right? So a lesson is like an investigation, right? So it's an investigation. So and an investigation is like an experiment that a kid can do, right? It's a unit of study.
It starts with
Right.
phenomena, just like, yeah.
Right. I should have mentioned that. That's the way this sometimes you get real familiar with things and you don't, you forget to mention things like that are very obvious, like what does the INV stand for?
Yeah, because yeah,
That's a good
that's a short form.
I'm gonna make a note to bring that up. Well, I'll remember that one, to bring that up. I don't tend to have any writing utensils around here. Do you have any other questions or comment? Otherwise, I'm gonna jump into the last breakout group.
We are actually still exploring, Prof. Joe.
Okay, keep exploring. That's what you're supposed to be doing right now, is exploring.
All right.
I'm gonna pop into the last breakout group and then I'll call everybody back together again.
All right.
Okay, Prof.
They have teacher guide in it in every investigation.
This pipeline prediction. What is the meaning of this part?
Okay,
Prof.
what
Joe.
that's just an outline in this teacher materials. It's to get kids, this is sort of like a basic outline and use this space to make notes to prepare your lessons. That's all that this part is for, right? So if you go into the teacher materials, you'll notice that, I mean, the student materials, you'll notice that one of the activities is for kids to observe what happens when you put a group of pie pans on a Van der Graaf machine. And we'll demonstrate that in a little bit. We're gonna actually look at that one. So,
Yeah.
that's what that one's about.
Okay.
Okay, well,
thank
I'm
you,
gonna,
Joe. So we need
any
to
other-
see the
any other-
student. Yep. So
Yeah,
we
then
need to
after this,
see the student material. Yeah. Okay.
yeah, you have to go back and forth, but I wanted you to get a sense of the structure of the teacher materials before you dove into
Okay.
the student materials. Okay, I'm gonna call us back together again. So let me I'm gonna pop out of here and leave this room and then call us all back in.
Okay. Joe is missing.
Hi, Joe.
Chair, you are mute.
Sorry, I thought, sorry, I've been talking for a while. I didn't realize that. Anyways, what I would like to do now is to bring out some of the ideas that you've noticed as you went through the teacher materials. And what we're gonna do is we're gonna spend a little bit of time going in to explore the student materials. And I noticed that Peter and his group put some notes in the chat. And so, Peter, I wonder if you want to describe what your group basically say what you said in your text message there.
Sure. Thank you so much. So basically, when we were reading on the materials, I think maybe we accidentally read the students' material. I'm not sure. But the thing is, the materials for me is actually, for us, is actually arranged in a very nice order. And it actually give guidance to preparations before class, before carrying out in class. Yep, it's also basically there are a lot of examples given, and it actually helps a lot for teachers or people who doesn't have the backgrounds in the materials, in the content, to deliver it to the students. So this is actually a very meticulously planned guide, and it's actually very good for teachers who actually doesn't have background even to deliver it to the students. However, we do think that there could be some alternatives because there are some of the apparatus might not be in the schools, as well as some of the items, or it could not be carried out entirely in certain schools, like for example in Malaysia, maybe in Thailand, or in Indonesia, whereby the weather is humid. The statics part could not actually work. I mean, it does require a bit of assistance from maybe doing it in air-conditioned room, as Joe have suggested it earlier, doing it in air-conditioned room of which it's quite dry already. Then yeah, other than that, I think maybe there are things examples that can be given in the materials after this. Also, there are multiple links. I discovered there are multiple links, and the links works. And it does have further materials for us to read and further materials for us to do research on, which is it's very nice. It's something that is very nice, but you do need to spend more time, as well as you need to spend a certain amount of time to read it completely before you can actually deliver it. Yeah, that's all. Thank you.
Right. So Peter brings up two really important ideas. The first one is that interactions is a substantial unit. And it brings up some really important learning goals that in the past you really haven't focused on. And so it's going to be challenging for teachers who have never taught this content, who have never taught in this manner, to actually implement the materials. And that's true in the United States or in Asia, where you're at. So we tried to really create the materials so not only would they need professional learning hands with other teachers, but also we tried to make the printed materials very educative in nature so that teachers could actually learn from looking at the materials. Now, the other point that Peter raised, and then I'm going to see if anybody has any other comments, is that some of these experiences might not work in Asia, in a humid environment. So I know they don't work in a humid. I've experienced it too. In very humid environments, many of these electrostatic investigations will not work. So if you take a rod and you rub it with a piece of fur, or a rod, and melt it with a piece of silk, it won't charge because you need to be in a dry environment. There are videos that you can substitute. It's not the same, right? Firsthand experiences are so much more powerful than secondhand experiences. On the other hand, if you can't do the firsthand experiences, the secondhand experiences would be very valuable for your students. Or if, as was, when I was in their breakout group, we did talk about if you have access to an air-conditioned space, as long as it's dry, these experiences will work, right? But you do need a dry environment. So before I sort of go through some of the major parts, I wanted to see if anybody else had any general comments regarding the structure of the materials. You can either speak out or raise your hand or. Okay, well, let me, I shared my screen with you that I think you can see in front of you. And I just want to highlight a couple of aspects. So first of all, in one of the other breakout groups, someone asked me what the INV stands for. So if you, I think everybody can see this, right? I just switched screens. Everybody see this okay? If you're on this page, you notice here it says INV. What is that? And the question was asked, what does that stand for? It stands for investigation, right? So when you click on investigation 1 and you go to it, investigation 1 comes up. You can think of an investigation as like a lesson, right? It's just that the way we called it, we wanted to get away from the concept of a lesson and talk about kids are really involved in doing something. So we called them an investigation. So you'll notice that each of these is made up by a brief overview of what's going to happen. And of course, the first thing you notice is that there's a lot of static electricity. There's Scotch tape, balloons, rods, various materials that might not work in a human environment. I'm actually going to ask you to try a couple tonight because they're actually really kind of cool, and I want to see if they actually work or not work. And of course, then there's the performance expectations, the big learning goals that that students are supposed to learn, and it's broken down then into the elements of the disciplinary ideas that the kids are supposed to learn. And of course, here the big idea is that the structure and interactions of matter at the bulk scale, right, the macroscopic scale, are determined by electrical forces within and between atoms. That is a really critical idea, and that's what this first investigation tries to help kids build an understanding of. The cross-cutting concept that's big in this one is patterns. Kids are looking for patterns in their observations that they make. And this particular unit investigation really focuses heavily on models. And of course, it tells you what the target model should look like. So we always try to provide what should the student's conceptual model at this point, after they get done with this investigation, what should it look like? So really sort of tells you where the kids are building towards, because these first 2 units really start off at sort of this low level of science understanding and really build. So it builds from why things stick together because of charges to really understanding why bonds are formed as we continue to go through. It provides some background information for you, and of course, this investigation. So you can read the background information. This investigation is actually broken up into a variety of different activities. So it's 5 activities. Maybe you might want to call those a lesson. We call them activities. Anyways, you can see we give you an approximate amount of time about how long it takes things to actually, it'll take you to use them in your classroom, anywhere from 45 minutes to 90 minutes. And then it goes into each one of the activities in depth. So this would be the first activity in this investigation. And it's basically about what are some examples of things that stick together and things that don't. And so this is actually getting kids to use their prior knowledge to really generate ideas. There, as well as experiencing some ideas related to a Van der Graaf. And so there's a summary of what the unit should be about. It then goes into depth about the student learning goals, right? The learning goal is brought up very clearly about what this particular investigation kids should get out of it. It amplifies the disciplinary idea, the cross-cutting concept idea, and the scientific and engineering practice. There's some points, it always brings up these points to consider as you're planning. Tells you a little bit about the preparation time, but the preparation, how long the class will take, as well as the materials you'll need. And of course, this particular activity is rich in kids experiencing phenomena, provided they can actually experience them in a human environment. It does talk about safety concerns. If you have a Van der Graaf, they can be a little bit dangerous, so you have a little cautious with them. So we bring out what the safety issues related to a Van der Graaf. And of course, you can click on any of these links and they're active. There are reading materials for the student that you can see. You can click on this and it brings up a reading material. As I just did, right? It brings up a nice little reading material on what models are, and it tells you when you can assign this. And this is sort of a space, because this is like the teacher version is print. So this, if you print it out, this is a space where you can add some of your own notes. And then it goes into a fairly detailed outline of how you actually produce, how you can actually implement this unit in your classroom. Now, one of the things I want to stress is that these are not scripted. We do give suggestions, possible questions that we like to think of these as educative features to help kids understand, to support the teacher in actually doing the lesson. But it's not scripted. These are just some ideas. Adding your own questions would be really powerful. And of course, then it takes you into the activity itself. Again, with lots of notes for the teachers, as Peter pointed out, really to help the teacher in understanding, what's going on. In non-human environments, you get all these kind of interesting things that happen. And again, these are in the student materials as well, because so if you're looking at this picture of a cat, this cat has all these little styrofoam packaging peanuts stuck to him. Why does that happen? Right? This kid's hair tends to be flying apart. Why is that happening? And so these are images and questions to really get the kids started to thinking about electrical interactions. And of course, one of the things we have is really getting the students to ask what questions they have about this. And so there's always a part in here where kids are generating their own questions, and that happens in the water unit, as you recall, and it also is going to happen here, where we really try to get kids to ask their own questions about why do clothes stick together, or why does your hair stand on edge. And once again, there's notes for discussion. Tells you a little bit about how to introduce the lesson. So an introduction of the lesson. Again, possible questions you might ask. Then there's a variety of demos that you can do. These are the demos that, again, that Peter is somewhat concerned. Will they work? And so you should try these actually. And then there's questions for discussion. So that tends to be the structure of the units. Then you're gonna get into this activity called this part 2 of this activity, which is the pie pan demonstration that we'll take a look at in the student materials and etc. So I'm going to stop there because I want to give you 10 minutes to go in and look at the student materials. So these are all related to the teacher materials, And what I really want you to do now, so I'm gonna stop sharing. And I'm gonna reshare. And what I want us to do right now is I want us to go and I want us to look at our student materials. Now, we're not gonna have 25 minutes. We'll just take 10 minutes on this. So I want you to go back into your breakout rooms. And I want you to look at the student materials just for 10 minutes, maybe tomorrow. Well, tomorrow for sure we'll go back in there and do some stuff, but I want to have you get a sense of what the student materials are like. And in particularly, I want you to look at the student materials on the Concord site for today. Now, if you don't have internet connections in your classrooms, then it's going to be much better to use the paper pencil version. But there's lots of advantages in using the online materials. As you go in and you look at them, you'll get a sense of what those advantages are. So I'm gonna stop sharing this screen, and I'm gonna go to my website again. Because I just want to show you how to get there. So I'm gonna share my screen again. But now I'm gonna share the Concord site. Okay. So everybody has been here and you're logged in. So if you're logged in and we click on unit 1, now instead of going to the teacher guide, what you want to do is you want to hit preview. And when you hit preview, that will take you to the student materials. So now I'm in the student materials, and at least for today, let's just focus on investigation 1 and investigation. Let's if you get through investigation 1 and move on to investigation 2, great. You might not be able to get there, but if you can, that'll be great. But right now, let's just click on investigation 1 and go to it and see if you can't work through it. As a lesson, it would be a 45-minute lesson. So just take a little bit, about 10 minutes. I'm going to call us all back in at 10:02 because I want to just point out some points. Be ready to discuss or bring up some points about what you notice. But let's spend 10 minutes in our breakout room looking at this activity and what you notice. So if we can go in the breakout rooms, great. Thank you. I, I have to go and explore that. I have not, that's an interesting point. It should work.
Uh,
And your volume is obviously up, so I'm not sure why you can't hear it. When we go back into the breakout rooms, well, let me just try it on mine right now.
Yeah. I couldn't get it to work, so yeah, that's why. Mm.
Yeah, is that cool? That's
Yep.
it's one of my favorite, I just love that demonstration.
That's really cool. Okay, now how do I
What
get back?
causes these
Oh.
things to happen?
Right, so,
Brainstorm with your partner and enter your ideas below.
so this is the
Oh,
way you go back to the previous page.
I cannot get back.
Just click on page 1 of the Van der Graaf.
Oh, yeah.
Okay, now scroll up,
Okay.
click on that thing,
Yeah.
and then highlight what you want to read. Now click
For
on
me, it doesn't come out.
it. Highlight it,
Okay.
and then click
Sorry.
on it.
Highlight this and then click on this. Is it?
Yeah, yeah. Oh, that's interesting. Let me show you how it works for me.
Okay. So I'll just stop
Hold on.
sharing then.
Yeah, I'm gonna share my screen with you. So, so I've got this open, right? So it's not closed,
Yeah.
that's closed, that's open. And if I wanted to read this part, I just come and I click on
What
it.
causes these things to happen? Brainstorm with your partner and enter your ideas below.
Do you see what
May I
did?
know what kind of browsers are you using?
I'm using Chrome.
Hair standing on end credit. Ken Bosma license. CC by 2.0 styrofoam
stupid.
packing
So
peanut
I'm gonna turn
sticking.
that off.
Okay.
So you basically turn this on and then click on what you want
What
to read.
questions do you have about
I'm
clothes
in
sticking
Chrome.
together and hair stand?
So
Okay.
I'm using Chrome, so that's why, so.
I'm using Chrome also, but mine doesn't seem to work. I don't know. Maybe yeah, there's something else here that I need to install. I'm not sure on that. Maybe I'll just refresh after this.
Yeah, it's a nice feature for kids, like in the US. Well, there's no way for us, we can get these translated into Malaysian. You'd have to do that. But in the US, we have a lot of kids who are not English speakers, they're from South America or
Mhm.
Asia. And so having this feature for them is very valuable
It
in the
is.
US. Yeah. Anyways, I'm gonna I'm gonna close the breakout rooms because I want us to get back by 10:02.
Okay.
So at least you had someone to talk to for a little bit. So I'm gonna go to the breakout rooms and just close them. So I'm gonna, I think everybody's back, so I'm gonna start. The first thing I want to point out, we only have a little bit, about 9 minutes together. I know that was really quick, and we'll spend more time on the materials tomorrow. But the first thing I want to point out to you, that Kessler wanted me to mention, it's in the chat. And these materials are called Creative Commons. They're CC BY, etc. license, means that they're anybody can use them. Basically, that's what they mean. And you're free to modify them. The only thing that you need to do is, if you use them, is give attribution to where you got them from. That means if you modify them and you change them somehow, and you want to distribute them, you need to give attribution back to the original developers. So, but so you're free to use these. You can remix them. You can use them any way you want, etc. Some of the videos, in particular, don't belong to us. We try to keep the links active, but again, all the videos, all the simulations that we used are all Creative Commons open source. And the reason why I'm pointing that out is you don't have to worry about using them and then somehow getting someone saying you owe $2,000 because you use these materials. These are all very clearly stamped Creative Commons open source, not-for-profit license. Okay, with that, I'm going to share my screen. Kessler, is that what you wanted me to point out?
Yes. Yes, thank you. Yeah, thank you, Joe.
Okay, so I'm going to share my screen with you. And I just want to point out some really important ideas right away. So I'm going to go into the preview of Unit 1. And I think everybody can see this. And these are some of I'd love for you to try some of these tonight. So this tape experiment, I actually wanted to try to do together. The only problem is one person can't do it. You actually need two people, because if you go into the investigation, you'll try it. But either tonight or tomorrow, if you have another person around, you really want to try to go in and do investigation too. I think it might work even in a human environment, So this is a really cool activity where you can actually charge the various, when you put two pieces of Scotch tape on top of one another and you rip them apart, you actually evoke a charge on both of them. One becomes positive and one becomes negative. And then if you do it with another, but you can't let them touch each other, right? So you gotta be a little careful once you rip them apart. And so you have to hold them. Then if someone else rips them apart, and you actually bring them towards each other, they'll actually either attract or repel each other depending on what charge they have. So it's really pretty cool. So I want you to, if a couple of you could just try that tonight or tomorrow during your day, you need at least two people. So you want to go into those materials and you want to read them. And you want to see if in fact you can't get that to work, because it's really a cool phenomena. The other phenomena that you might want to try tonight or tomorrow, I keep saying tonight, but you're going to sleep tonight and tomorrow morning you're going to get up. Anyways, sometime between now and our next session, if you could try this one, this is also a really cool one. All you need is a water bottle and a piece of fur or a piece of silk. And if you rub the bottle, you can actually control the movement of the bottle, right? You can use your hand, and because the bottle's charged and your hand's neutral, there's actually a difference between them. So you can actually make the bottle go forward and make the bottle go back. And I've seen people who are, students who typically aren't engaged in class play with this for 10 to 15 minutes because they're so fascinated about why does this happen, right? Because they have some sense of power and control over it. So I really want you to try these two experiments, this tape experiment and this bottle experiment on your own. it's really hard for me to try to demonstrate it, but I can't do the tape one. So you're gonna need a partner to do the tape one. Now with that, I'm gonna drop us in the into activity 1. And some of the features that you'll see that are really I really like about again, I'm gonna be very honest, I'm very biased about these materials but please, you should make suggestions to how to improve them. I think this unit really deals with some important lessons, and there's lots of interactions. That's what I like about it. So kids are always putting in some information before they can actually move on. Now, here's where the kids are actually gonna draw a diagram of what happens when they see this Van de Graaff. Now, if you didn't notice it, when you actually come into here, you can actually play. You can, if you don't have a Van de Graaff, there's a video of it. You click on this PyPan demonstration. And can everybody see this? Should see a Van de Graaff machine. Yeah. Okay.
Yeah.
And thank you. And if you play it, you see what happens. And the question becomes, why does that happen? Why when you turn on this device, will these pans just fly off of it? Now, it's wonderful to play in the video, but when you do it real, it's even cooler. And this is another example of this phenomena some people just get fascinated with. And they can watch this video over and over and over again, or play with the Van de Graaff over and over and over again. Why? Right? So it's it's really interesting about why does this happen? What's going on, right? So this is starting the unit. So you might, if you haven't seen that, I just kind of wanted to show you that indeed in these materials, there's lots of embedded aspects as well, right? So you can play these videos or not play these videos. Okay, so I'm going to go back to the materials again. The other thing I wanted you to see, and if you didn't notice this, again, we only have this in English, but we do have it if you click on this thing where it says tap text to listen. And I know Peter, this didn't work on Peter's machine, so you need to try it on your machine. But if you click this thing that says tap text to message, and then you go and you stand over something.
Now that you've seen what happens to the PyPans after the Van de Graaff generator is turned on, make 2 drawings to show what caused the PyPans to behave the way they did.
Anyway, so it will play for you the text. And so for students who are poor readers, this is a very helpful feature of the materials. So we're ending our hour together. So as I just going to go back here and just shoot, it's not what I wanted to do. I just want to go back here again. And I just want to say, if you have time tomorrow during your day, if some of you could see if you can't get the tape experiment to work. It's a cool, I like it. Of course, I'm biased. It's a really interesting phenomena, as well as the bottle phenomena. So if you could try those, that's great. This unit has a lot of, because there's such a focus on everyday phenomena in this first unit. It really can help. It really sets a really nice context, really sets kids' interest in wanting to learn why these phenomena actually occur and what's going on, right? So it's a really nice way of introducing the electrical nature of matter, and that electrical forces actually do a lot in our world, right? We're typically not aware of them, but electrical interactions and the forces between them are so critical in a lot of the phenomena that exist. And for kids to build up an understanding of why these occur, will just allow them to continue to understand more and more phenomena about how the world works. Okay, so tomorrow we'll do part 2 of interactions. Once again, it's impossible to go through the whole thing, so you're going to have to do a little work on your own. Come with questions if you can. Try to look at units activity 1.2 and 1.3, and then we'll go further into the second unit tomorrow. So have a good evening, what's left of it, and have a good day tomorrow. And I will see you in your evening tomorrow and bright and early my time tomorrow morning. So have a good evening. Talk to everybody later. Bye-bye.
Bye bye.
Thank you.
Bye bye.
Bye.
Thank you.